Hello there and good morning. So, I've been posting a couple of videos onto my channel, kind of going over some projects that I've been working on and just kind of making explanations for them, explaining my reasoning behind them, allowing me to kind of uh, intuit them a little bit, and then also kind of hold myself accountable. So, yeah, the GPT project, or the junior GPT project specifically is kind of what I have in mind here. But today I wanted to talk about another little project that I'm working on, which kind of complements that project, but also has a fundamentally different sort of reasoning behind it. And that is this. I don't really have a good flashy name for it yet, but I'm just calling it the assistant framework. And it's under my Quasar Brains GitHub organization, which I'm kind of using as a place to build tools that developers can use to easily automate their lives and workflows. And yeah, so the assistant framework is essentially supposed to be a declarative method for building out digital assistants based on language models. Now, the reasoning for this kind of goes into some, more technical details, but essentially is that a declarative framework like this, I think, is an excellent way to actually allow assistants to be built. And it was inspired by React, and I want to say that because it's essentially like the reason why React is so useful is because it gives you a declarative way to outline an application, and this level of abstraction that it provides makes a lot of little things like DOM operations and such. It gives them a sort of structure and allows you to focus more on like the logic and the features itself than the core implementation. And that's without getting too much into like React itself and how it contributes to the whole discussion around web development practices and such, because there's a lot of debate around that. But more just the fact that it is a declarative framework. If we look at react.dev, I wonder if there's a well, okay, I don't want to get too far into React itself anyway, but essentially it's a component based architecture. And so because it's component based, you can essentially extend it really far. There's a core utility of it, and then you can extend beyond that core utility and build your own application, but it provides just enough abstraction in a declarative fashion that you can, and that's also why it's a leaky abstraction. But because it's all declarative, it means that it's really nice. It's a really nice way to outline the logic of your application and the architecture of your application and stuff like that, which can also be its downside, and possibly that will be something to consider with this framework that I'm making. But now to get into the framework itself. So this is my first time really making an NPM package, so bear with me a little bit here, and if anybody has tips on how to improve that aspect, then I would appreciate that. But there are essentially two packages in the main monorepo, which uses Turbo. And the first one is Assistant, and the second one is Assistant Server, which is really just a utility for Assistant. But Assistant is the core, so I'm going to click on that because I want to kind of go through this README. So right off the bat, have this little tagline: an infinitely extendable assistant framework to automate your life. So what exactly does that mean? The idea is that you can extend this framework based on the core utilities, the core aspect. You can give it your own you can basically extend it to do all the things that you want it to do, and then obviously build automations from that. So one thing is that as of the time of recording, it is pre-release and there's some functionality, but it's quite a bit away from 1.0. Right now we're at like 0.3.0, and I mean, that's just the minor release that we're at. I'm not considering it a major version yet because we're just not quite there yet. But yeah, if you're interested in testing it out, there is some core functionality. And so the description, assistant is a declarative framework for building out complex, powerful digital assistants, acting as a wrapper around a language model of choice, most notably GPT-4 or GPT 3.5 Turbo, the OpenAI models essentially. The assistant frameworks provide additional functionality and utilities to extend the model. Most notably, the model will have access to services, events, and channels. Through a combination of these core utilities, your assistant will be able to communicate with you, channels, pay attention to the world, events, and take action in any way possible through software, services. And yeah, there will be pre-built services, channels, and events, as well as other helpful functionality to get you off the ground easily. However, the infinitely extendable aspect of the assistant is the ability to easily add your own functionality, etc., etc. So, real quick, I kind of want to dive into, what services, events, and channels are. These are kind of a concept that I came up with when I was doing a little bit of introspection as to how I might take up the role of an assistant, and also like what assistants really do for the people who they work for, and also the things which they need in order to accomplish that. And so first of all, we have services, and services, I do have documentation on services, I believe. Oh, I do not have documentation on services, but I will. So services are essentially a way of modeling out actions and capabilities for a model, and I'll show some examples later when I get into the actual code base. But essentially, think of services as sort of predefined abilities that you can give to the model to actually perform. Events, these are something which hasn't actually been like put into the code base yet, but essentially the idea with events is that this is sort of the a stream of information given to the model that essentially says like, hey, this thing happened, react to it. And so that's the idea, is it's sort of the reactive mechanism, so that if there's a weather update, or like you could imagine potentially tracking weather alerts as an event, and if there's a weather alert, then perhaps your assistant dispatches a service, takes a specific action. Maybe it sends you an email. Maybe it gives you like a reminder of all of the things that you should potentially have prepared. You can imagine it does a variety of things. If you have it connected, my goal is to eventually have a bunch of robots running around, performing certain actions. And so, maybe having it, all of the faucets sort of start dripping, like because of certain weather alerts, could be an interesting capability of these assistants. And it's essentially just pays attention to a stimuli, takes an action as a result. And so that's kind of what events are. And I think that this ability to react outside of specific instruction is going to be a big part of what assistants are able to do, and part of the autonomous nature of these assistants. As of right now, we have Google Assistant, we have Amazon Alexa, we have Siri, we have, I think Cortana is still a thing. I'm not entirely sure though. Essentially, we have digital assistants, but all of them are more or less reactive in nature. There's some functionality for built into applications where it's like, when this thing happens, you can set up routines essentially, which I think is an interesting concept. If the event happens that the time changes to this time, then do this. And so we sort of see that kind of functionality, but it's mostly reactive. And even events would be reactive, although it could take some sort of action as a result to those without necessarily having a predefined like programmed routine. But the also interesting thing that I want to look into more is giving assistants the ability to sort of take initiative, and that's something that I think I'm going to elaborate on more in the future, because it's not something that I've thought about too much. And then lastly, the last real like core principle is channels, which are essentially just ways of interacting, like communication, essentially. So you can think of Slack being a channel, and perhaps text messaging like SMS being a channel, email being a channel, a server being a channel, and that's something that we'll actually see when I kind of go through the code a little bit. But yeah, so essentially these are the core utilities, and all of them are built with common interfaces so that you can set up a channel or an event or a service, well, events not yet technically, or a service to do anything, but it implements a common interface that the model can actually understand. And the model is also language. The framework is also designed to be model agnostic, and so you should be able to implement any service and also use any model. And if it all uses the same common interfaces, then you can just hot swap these at will. So it's essentially like, oh, I want, there's a new open source model out. I want to use that model. Okay, cool. Just swap out the GPT-4 model that you were using before. Put in your new open source model with the wrapper sort of built around it, and then everything will still work as desired. So the idea is to maintain backwards compatibility, but also to allow for a large degree of modularity through this. But I mean, one of the things that I really was thinking about initially is like, what is the difference between agents and assistants? And one thing we'll see when we get into this project sort of code and architecture is that agents do exist within the project, but they are a secondary. They're a secondary sort of technology, and assistants, I think, are sort of almost fundamentally different than agents. So I kind of outline this here. There are many projects such as AutoGPT, Baby AGI, and others which employ a concept known as agents. These agents can be described as follows: a program given a goal, or agency, which it will then develop a plan in order to complete, and then use tools at its disposal to follow its plan. There are a lot of lessons to be learned from agents, and it's very possible that they might even be employed as part of the project, which did end up happening. However, there's a fundamental difference between an agent and an assistant. An assistant does not have a goal, it has a purpose. It does not have a discrete set of steps in order to fulfill its purpose, but rather must exist in perpetuity, ready to receive orders or take initiative in order to fulfill it. This is the key difference between an agent and an assistant, and why I'm creating this project. An assistant will be capable of dispatching agents. However, the agents ultimately only exist to fulfill one task, hence their agency. The assistant exists to continually provide the service to the user. So yeah, that pretty much sums it up. The idea is just that, like, while a agent has a specific goal that it can work towards and is a really good architecture for actually building that, an assistant, you can't just say, oh yeah, give this assistant this particular agency and then have it make a plan in order to actually complete it, because it sort of has to exist in perpetuity and exist reactively to whatever it's working for. So yeah, now I do want to get into a little bit of how this actually works, and before we get into some of the demo code that I have up, and I do want to stress that the documentation for this isn't full yet, and I really do plan on making it more full. So the way that this all works is it's centered around this sort of assistant class. Now, before I get into the way that this all works, I'm going to go over to the test server application that I've kind of been using as an implementation sort of example and testing environment for this framework. And I want to explain how this might look in sort of in practice, how you might actually implement this. So first of all, this is implementing two different packages. It's implementing the assistant server package, and it's implementing the assistant package. And then it has, Express, and then we have some services, which I'll get into. And, we're configuring our .env so that we can actually pull the environment variables from the .env, and trying to find an OpenAI key and a webhook URL. So I'll get into kind of what that means. First of all, the OpenAI key is probably the most important part here, just for setting up the assistant, because you need that in order to actually set up your model. But the way that you actually create an assistant goes with this assistant class. So this is imported up here from the QuasarBrain's assistant framework, and we sort of fill out all of the configuration for it. So I'm giving this initial model the name, this assistant, the name Onyx, and now I'm going to create a new chat model instance and actually assign that to the model. So that's what the assistant.chatmodels.openai does, and theoretically there will be more options for creating chat models, including a custom model. But for now, you give it the API key, and then you have the agent model and the planning model. Now, I will say that the agent model planning model dichotomy might go away, because I'm not entirely sure that I like how it works, and it stems from some sort of deeper architectural decisions. But yeah, so that those might go away, and the specific configuration doesn't matter as much. But essentially, you take the interface, the assistant.chatmodels.openai interface, and you use that, you configure it, and you provide that to the assistant as the model that it will use. Then you give it a data store. This is just for logging purposes. You set verbosity. If it's more verbose, then it will provide you with some more output and sort of logging as different requests are fulfilled. You probably usually want this off because it's not necessary, but for debugging it's useful. And then you give it a little bit of a description, which will be used in its prompt. Then you come over here to the service manager and you register services. Now, the reason why you have to register these services is because this is where the actual extensibility comes in. So if I go over to these services, I can say that services as a variable is just an array of different instances of services. So let's just go to one of the services that I have declared. You can see that over here we are importing services from the services file, which is exporting an array of service instances. And so if I go to the Axios service, which is the first one on here, then you can see how this is actually instantiated. So the Axios service class extends the assistant.service abstract class, which describes the interface required in order to actually make a service. And then within here, so first of all, you'll define the name of the service, you'll define a description of it, and then you'll define the different methods available on the service, and then you'll actually implement those methods. So that's sort of the idea here, is a service is implemented as a class. Class has a bunch of different properties on it, different methods available, but the way that they are actually defined and then later performed by the model is through the JSON schema sort of implementation that OpenAI uses. So the way that I'm describing this here, let's say I want a service like the Axios service, which uses the Axios library to make HTTP requests. So I want to probably do a couple of different things. First of all, I want to make GET requests. GET requests are useful because, you want to get data from a certain URL. And I also want to be able to make a POST request. So, maybe perform an action to some random server. those are just implemented as methods. Simple enough. You can have as many methods doing as many things as you want. Now, over here in the methods property of the schema, you define all of the different methods that you want to give the model access to. So, well, the first one is obviously going to be called get, and this corresponds to the method called get. So description is going to be provided to the model using the tool calling or function calling or whatever they call it by the time this is actually like really in use, and it's going to describe to the agent what this method actually does, and then we give it the parameters. This needs a URL and then it needs params. So, and then the URL is the thing which is required. Now, there's another property of each of these methods, which is perform action. And so this essentially will take a parsed JSON object and it will attempt to perform the action using those arguments. Now, it is worth noting that this is where sort of things like validation come in, and I'm not giving a good example of that here because I don't have any validation. But because due to the non-deterministic nature of these different parameters that will be passed in, which I'll show off a little bit more later, the validation needs to kind of happen at this step per method. And then, I did the exact same thing with post here. And so that's how you would actually implement a service. So now you can see that in this array, we're instantiating a service, and the specific way that you actually implement this is up to you. Ultimately, what needs to be passed to the register service method of the service manager is an array of service instances. So that's all that this is. It's a bunch of different services. Register service wants a bunch of different services, and yeah. So this is actually all that you need as of now to technically set up your own assistant. Now, putting it to use is a little bit of a different story, and that's where the assistant server comes in. So first of all, we need to get our port and our webhook URL. So the port, that this is fairly basic server stuff, so it doesn't matter too much. But you have your port, and then you have your webhook URL. Now, the webhook URL, this is actually required because the assistant server works by creating a channel that uses basically the input is a request and the output is sending a post request to a webhook. So that's kind of the way that I thought of to actually make an input output sort of thing work with a channel. So with a server, because that's what a channel is it's a line of communication, so it needs an input and an output, and so the assistant server provides that input and output by having an input be a request to the server, and then an output being, because there needs to be some you can't just do everything within a single request. The output would be and the agent needs to be able to proactively send through the channel different information. So the output is the webhook. That'll kind of make more sense probably because I'm probably not explaining it very well later. So you give it some properties in the configuration, you give it the actual assistant that is being used, and then you give it the webhook URL, and you also define log. This should probably be verbose like before, but we'll call it log for now. And you give it that log property. I set it to true here. You instantiate the router, so you do the assistant server, which is this up here, .router, so you get your router, and then you set up an express server, and you just point the router to this express server. Now, what I will say is that as of now, this is probably not as framework agnostic as it should be. And I'm just kind of thinking of this now. If you don't have an express server, I'm not entirely sure this would work because the router exposes it. Oh my goodness. Because the router method exposes an express router. So as of right now, I think this would only work with express, but I think I'll make an issue of that. I'll do that right now, actually, just to make sure that this actually ends up getting fixed. Right now, it will only work with Express, but ideally it would work with other frameworks. Make assistant server framework agnostic. That being said, you could certainly assistant server only works with Express right now. It should work with more than that. Okay, there we go. Yeah, ideally it would be framework agnostic because we want everybody to be able to use this. So we create our Express server. Notice we're also instantiating an IO server, a socket IO server. This is because when the webhook actually happens and is called, we want to be able to basically tell the client, hey, there's more conversation data, pull it, essentially. So this is just a way to kind of instantiate you can see it actually happening here. When the API/webhook callback URL is actually like posted to, we're going to emit that there's been an assistant message and then send that data to the client. So this is kind of just how you might expect a kind of traditional server to be set up. And this is a test server, and obviously it isn't super comprehensive. But what it ends up doing is it serves this HTML file, which has some logic in it, which I'll actually demonstrate now. So if I run pnpm run dev, then it's going to get everything kind of up and running. And then if I go back to my browser and I go to localhost 3001, then it brings this up. I can't guarantee that this will 100% work. It's likely that we'll have some logging pop up and it may not. But first, what I'm going to do is I'm going to just say hello. Now, theoretically, what this should do is, okay, cool. So first, it sort of makes a plan. And we'll actually see this kind of in a little bit more of a deep dive into how the code works itself. But first, what it does is it picks a bunch of discrete actions. You won't see this logging if you have verbose off. So it picks a bunch of action groups. Now, discrete actions are actions which are essentially indivisible, and then if they are dependent on one another, then they will be put in a group together. So groups of discrete actions will be made if said actions are dependent on each other, and if those actions aren't dependent on each other, then they'll be in different groups. So it creates a group here, and you can see that this is just given the name group 1, nothing very interesting by the agent, but it's defined as respond to the user's greeting, and it's sourced from hello. So because the user said hello, it's going to define the action respond to user's greeting. And then for each different group, an agent is dispatched. So agent 503495356 has been initialized to complete the following task. Group 1, which has the actions respond to user's greeting, and yeah, so nothing very interesting. Dispatched agent for action group group 1 with name 503495356. Not a very nice name. But then you can see that the agent actually does perform an action. It says, hello, how can I assist you today? So, not super complicated. And obviously the logging, the actual the actual code per, the actual execution per request ratio might be a little bit off because a lot is being done just to say, hello, how can I assist you today? But that's essentially what it does. It defines, I'm going to respond to the user's greeting as an action group. Then for each one of those action groups, it's going to dispatch an agent. The agent is going to say, hello, how can I assist you today? And then agent 503495356 performed action send message. That's one of the actions defined on every channel with arguments, message, content, and then hello, how can I assist you? And output undefined. So there was no output from the send message. And then, so then because that was the only action, it'll then say, once the agent has finished with all of the things in its group that it was dispatched for, it'll say it has finished, and then it'll give the action history. For action, respond to user's greeting. Performed action, send message with arguments, message, content, hello, how can I assist you today? So all of that was done to say, hello, how can I assist you today? But the only thing that you need to do in order to actually make that happen is, in this case, obviously, there's some infrastructure set up around the core assistant in order to set up this sort of server. But all that you actually have to do is instantiate this assistant and register some services. Now, what I didn't do is actually use any of these services. As you can see, it actually we do actually have some services here defined. We have the file service, the Axio service, and the email service. I am actually going to ask it to make a GET request. Let's go over to my website. Let's go to my notes, and then let's make we'll go over here to my new PC, which is just a list of all the things that I kind of want in my new PC. And then I'm going to have it make a GET request to this web page, which has HTML on it for my new PC. Now, this is a live fire test. I don't know if it'll work. Again, this is early development, but what it should do, if I say make a GET request to this URL, and then summarize what is on the page. If I ask it to do this, it should make a couple of discrete actions. Hopefully. Okay, cool. So, pick discrete actions. Oh, hold on. Before we get too far up here. Oh, okay, cool. Hold on. So, make a GET request. Now, this might not work, but it should show us more about how this actually ends up working. So, pick discrete actions. So, it creates a group called first task. I need to work on that because that doesn't really define what's actually happening here. Make a GET request to the URL. And then the second part is summarize the content of the web page. So, it needs to make a GET request to the URL and then summarize what's on the page. So, agent has been initialized to complete the task. Dispatched agent for action group. Performed action GET with arguments this, and then it sends back the HTML of the page. Then it says, okay, so it outputs all of it just outputs all of the HTML, and then agent has finished, and the agent says the best tool for this action is not in the tool list. As per the action, a tool that performs text analysis, extraction, web page scraping, or web content summarization is required. However, such a tool does not exist in the tool list provided. Hence, the assistant should notify the user that the action can't be performed with the available set of tools. The function's send message function can be used to notify the user. Now, this is fascinating, and this is one of the issues that might arise with this. It's essentially tasked with always using a function, and what's happening here is that it doesn't actually see that there's a function which is relevant. In this case, I asked it to summarize what's happening, what's on the page. It doesn't have a tool which specifically correlates with that. Now, what I wanted it to do was use the send message function to tell me what was on the page, but it didn't do that. Now, that's fine, but as you can see, it did actually grab all of this data all by itself, given that service, and theoretically, with some tuning, it would also give me a summary of what's on there. Then it says, for action, performed this. So it only really made one action. It didn't actually make a second action for this. I have a fallback so that if it responds with just text, then it'll just use the send message function there. So yeah, that's kind of what happened there. Now, I want to kind of step through how this actually works under the hood. So first of all, I want to go through what the actual server package does. So let's go to server and then index.js. So server, I mean, all of this is going to be kind of library code from here on. So if you're not as interested in that and you're just kind of interested in the implementation, I would recommend going and checking out the README and just kind of learning about the project from there. It is early stages, documentation isn't extensive yet, but you should be able to go to github.com/quasarbrains/assistant and then navigate yourself around there. So I'll show this URL up on the top, and I'll also have this linked in the description below. So how does this work? Well, first of all, we have the server class. Fairly simple stuff. We're using Express by default here. I want to make this agnostic to whatever framework you're using to build your server, but right now it's just using Express. Now, oh, interesting. So I actually have some test code in here that should probably be removed. But the way that the server works is it does a couple of things. It abstracts a couple of different things. The first thing that it does, which is of importance, is create a server channel. So a server channel, and I want to create a demo where I actually, create a new channel from scratch. And a lot of this stuff is just like, I haven't had time to actually implement these things yet. But so you take the assistant.channel class, you configure it, you give it a name, you give it a description, and then what you do is you actually have to, as per the channel constructor, you have to define a send message, a define conversation history, a get full history, and a get conversation history method. You have to define all of those, and they have to fit these interfaces. Now, what I might do, because I made the channel class before I made the server class, is I might make the channel class an abstract class instead, so that when you instantiate it, you can sort of do the same thing that you did with like services over here, where like with Axio service, you extend the assistant.channel class and then, sort of implement the interface of that. I might want to do that because that might allow for a little bit more flexibility in how things work. But as of right now, it's a little bit crude because this was one of the first things I did. And you essentially just want to provide it with all of these different methods. So the first method is to actually send a message. So this is actually used by the server. This is actually used by agents to send messages to the client, and we saw that up here, the functions.sendMessage function that's available to it, and it uses that. It pulls it directly from here, and it provides it with a message, and essentially posts. But then the logic of what it should do with that message, which is just a string. Actually, it's not just a string. I lied. A message has a specific interface, but what it actually does with that message is it posts it to the webhook URL that's provided in the configuration, which we saw, in the test server right down here. We provide it with this webhook URL. This is defined in the env. We have the webhook URL, and don't worry, I'll be deleting my, because I accidentally just exposed it, I will be deleting my API key. But webhook URL is provided in the env, and then essentially is used by the server over here to actually implement that. Now, I don't know what it says that I did to, so, okay, there we go. It says that this is an uncommitted file, so, or an untracked, or that there are untracked changes, so I don't know what I did, but that's fine. I'll fix that later. So that's the first method, just actually sending a message. Then there's add to history, which is essentially modifying a concept called the history of a channel, and that is yeah. So that's interesting. That implements the server history, which we saw up here. It's essentially just test is the name of the conversation, and then it's a list of messages in that conversation. That way you can be managing multiple conversations at once. And then we have get full history, which returns the server history, and then we have the defined conversation history. So this is essentially, and then get conversation history as well. So this is just kind of defining a bunch of different methods for modifying a common channel data structure, which is just kind of a bunch of a bunch of conversations being managed over time. So this allows conversations to be tracked historically, and as of right now, they aren't. They're only memory based, but eventually this will be persistent. And so yeah, that's what it does, and then it basically registers the channel in the assistant channel manager, and then provides a router, which returns this dot router, and then I want to see this dot router. This is going to equal router. Where is the part? Aha, here it is. Okay, routes. So we're also initializing routes, and what happens here is that first of all, we're defining a little bit of middleware, because we basically want the server to have access to the assistant and then the server channel, and then also the server itself. So we're just defining a little bit of middleware for these routes, and then we're also giving it these routes to actually use in the middleware. So if I go over here to the routes, you can see what actual routes are being instantiated. The first one is just a little, root route, which says, hey, this is, the assistant server. Then we have the post route, which allows a message to be posted to the server, and then it will grab the message right here, and it'll grab the conversation ID, and then if neither of those exist, it's going to get mad, going to throw a 400, and then it's going to, this is where the magic starts, start an assistant response based on that message provided to it and the conversation ID. If that's not started for some reason, if there's an error, it'll say there's an error. Otherwise, it'll say message received, and it'll respond with that. So you can see it doesn't make a response. It doesn't automatically generate anything right off the bat and send it back as the response. It says, hey, I heard what you said. Now I'm going to start responding to it. So, it basically responds before the actual response. But this is where the magic happens. It starts a start assistant response. So server channel start assistant response. It's also worth noting that every channel has this start assistant response method implemented by default. So, that's nice. But let's go over to what this start assistant response actually does. So the start assistant response, and this might also be a reason why having the channel be in an abstract class for other classes to implement might not work as well, because these methods all have a predefined implementation, and doing logic like that I don't think is possible in an abstract class. Anyway, so start assistant response. This takes a message and a conversation ID, and then it basically dispatches this receive message method given the message and conversation ID. And it also, I also want to mention just real quick that this kind of part of the day, like the way that all of this works interchangeably is kind of complex, and if I'm not conveying it super well, that's my fault, and it's also partly because I have a hard time just wrapping my head around this all in the first place. So if you're confused, it's probably because I'm confused and not explaining it well. I'm happy to answer any question. So then, based on the message provided in the start assistant response, call, we're going to grab the history. We're going to grab a response from the start assistant response method, and then we're going to respond whether or not that actually was given. But the important part is this receive message call right here. So in receive message, we're actually going to define conversation history. So we're going to essentially say add this stuff to the conversation history, and then for every one of the message listeners on this channel, which is another thing which I haven't really gone into, it's basically going to do a callback. So yeah, this is a way to like sort of wait for messages on a certain channel and then perform certain functions whenever those messages are received. But yeah, so this is sort of just an event-based thing where I got started with this, but it's not actually doing much yet. Anyway, because I keep digressing, we're going to, where was I? Yeah, right here, start assistant response. We received the message. That basically just kind of adds everything into the history. And then because this isn't an async thing or anything, this is all happening. I guess it is an async. We're also going to grab the history, and then we're going to start the assistant response on the assistant itself. Now, this is where the magic happens. Because what it's first going to do is it's going to see, does this message belong to an agent? And if that is the case, it is going to receive an agent message. So you can, while agents are doing their thing, you can send them message specifically. That's the idea there. And then it's going to actually start the pipeline. So it goes over to the pipeline class, which I haven't explained yet. And then it's going to take the user message, and it is going to call that method, the user message method. It's going to give it all the messages. It's going to give it the primary channel, which is the channel which is actually being used to start this assistant response, which we have being passed in here. And then it is going to give it a conversation ID. Based on that, the pipeline response is going to be generated, and then that's going to be returned. But the pipeline response is just a Boolean, basically saying, was this successful or did it error out? But this is where the user message that was sent, as long as the channel, are actually going to be utilized. So the user message takes messages, primary channel, and conversation ID, as we saw above. Then first thing it's going to do is basically just do some validation, make sure that everything's in place, the model specifically. Then it's going to generate the discrete actions. We saw that up here where it generated the groups of actions. This is where this is actually taking place. It is going to take the latest message, and specifically the content on that message, and it is going to get discrete actions. It uses this system prompt, which says, you are a discrete action. Hold on. Close primary sidebar. You are a discrete action extractor, and your role is to take user input and transform it into a structured format. It gives it some different information about this. This is where I could probably modify it to actually work better. And then it basically gives it the function and says, hey, perform this function, extract all of these sort of groups, and basically return that. So this is where that's actually where this discrete action groups are actually generated. So hold on. Where's the user message? Gotta navigate around. Oh, wait, because I'm in the wrong class. Okay, so we're using the model to get discrete actions for that message. If they aren't provided, then we're just going to say, sorry, no discrete actions found, basically make this a log, and return false. But if they are provided, first of all, we're going to do some logging up here, which is, where this stuff comes from. We're just kind of sending messages. You can see actually that it's utilizing the primary channel. This is a sort of aspect of this, which is the channel which is used to make a call to the assistant is also used throughout the sort of cascade to continually send messages and perform certain channel responsibilities and such. So it's going to utilize the channel, which in this case is the server channel, because that's the one that was called in order to make this, in order to actually utilize the assistant. It's going to send a message through that channel saying picked discrete actions, and then it's going to send what those discrete actions actually was with the type log, which is used by just like the front end to actually display this correctly. And yeah, you can see the exact thing happening here. So there's some infrastructure setup required for this, which will probably not be easy to set up without reverse engineering as of now, because my documentation isn't extensive yet. But yeah. Then for each one of the groups of discrete actions, it's going to create an agent. It's going to instantiate a new agent and dispatch it for that group, for the primary channel and the conversation ID. And then this is where we get the dispatch message. So for each one of those groups, how is the dispatch process actually going to work? First, we have the action group itself, which is essentially defined like so. We have the name of the action group and then the actions themselves, which all have both the defined property and the source text property. And then we have primary channel, and then we have primary conversation ID. So primary channel is just what channel was used to actually make this call, instantiate this action. And then what is the conversation ID, so that we can keep conversations coherent. It's going to do its validation, and then it's going to generate a name for the agent. This is just a static class which uses random bytes to create a new name. So yeah, that works. It just needs to kind of make a unique key for the agent. And then it instantiates the agent. It gives it its name. It gives it its model. It gives it the primary channel. It gives it the action group. It gives it the primary conversation ID, and it tells it whether or not it should be verbose or not, based on whether or not the assistant was given the verbose parameter. Then it registers the agent. Notice we're on the agent manager class. It registers the agent to itself, and then it initializes and starts the agent. So yeah, so we're registering the agent. That's really just saying, register the, it's basically saying, okay, register the current manager to the agent, and then register that agent to the manager. That way there's a connection set up, and there's actually a managerial ability. So then that gets into what the agent actually is and what the agent does. Because when we come down here and we dispatch the agent for the agent group and we hit init and start agent, it'll take the name of the agent which was generated. It will grab that agent from the current list of agents, and then it's going to hit init, and it's going to hit start, and it's going to initialize. It's going to call both of those methods. So over here on the agent, sort of side, we have the initialize. We have the initialize method, which is called. If options are passed, then it'll actually utilize those. So first of all, if name isn't provided beforehand, then in the initialization it can generate the name. But the real interesting part is the start method, which first of all sends a greeting message, which is just kind of what we saw over here. Has been initialized to complete the following task, and then it stringifies the task that it has. And then after it sends that greeting message up here in, where is it? Up here in start, it's going to start the agent process. Now, this is the part of the entire thing which I think needs the most direct fine-tuning. But this is also where all the magic of the agentic process takes place. So first thing this is just kind of a recursive thing which runs as long as there are still actions that need to be performed. So first it'll check if there's no action group. If there isn't, it's just going to return because that's an edge case. If it's paused, there's a sort of pausing utility to all of this, then it will also stop the loop. If it's done, then it'll also stop the loop. And if it is out of actions, if all of the actions have been performed, then it is going to finish and return true. So then the actual implementation logic is it'll grab all of the unread messages. So first of all, it's just going to kind of get a sort of state thing going on. So you can send it messages, and then it will utilize those messages it'll basically, for each iteration, it'll see, hey, have I gotten any messages from the last iteration? And then it will have that added in the actual context string, as you can see here, in the perception. And if you look into some of my other videos on autonomous agents, you'll see that I have some information about what I actually kind of define as perception and how perception is built for agents. But anyway, so we have this perception string. This is the prompt which is used over here in this response, which is get action to perform for discrete action. And first we have to provide it with all the tools. So we actually are going to take all of the different modules that we have available. So modules being services, events, services and channels, and then it is going to convert those for tools for the specific model. As you can see in the abstract model class, the LLM, the chat model class, it just has an abstract class which takes all of the different modules, which are sort of predefined, and then converts them into tools. So every chat model will have an interface to do this. And then that way we can remain model agnostic. And then it is going to generate a response based on that. It's going to give it the action, the current action that we're on, which is defined up here by, it tracks the action group. So this will be something like summarize the content of the web page. Then it gets the tools. So those are all the modules. Those are all, and we can actually see how this is laid out over here. It gets all the services. It gets all the channels. It defines the other services, like the agent service, and then it essentially returns all of those as a big string of modules. And then in the agent process itself, it actually converts those all to tools for whatever model it's using. And then it sends get action to perform for discrete action, which takes the action, the tools provided, so the channels and services, and the current perception, and picks a response. This response is then used to pull out the arguments, the name, and the perform action method. And so the arguments are parsed, and the output is logged, but basically perform action is called, if you remember each of these services, like the Axio service, each one of these has a perform action property on it. That way, over here, all that has to be done from the LLM response is parsing the arguments, and then finding the perform action, and then using the arguments sent back by the LLM, it hits that perform action method, and then so that's how all of this was generated, because it performed action get, which is defined up here with arguments, and then it gives it the URL, which is what it wants. It wants the URL and then the params. And so it performs the action, and then it performs that information, it pushes that information to the action history. It adds the output to the context as well, which is up here defined in the perception. And then it sends a message if it's verbose. And then it iterates the current action so that we move on to the next action, assuming success, and then it moves on to the next step in the recursion. So there are modifications that can be made to this, and I also just real quick want to define how actually, since this is a model agnostic thing, just assume that this sends back a response which is consistent. You have a module method. It sends back a response of a module method and the arguments for that method to be called. So you can assume that this get action to perform for discrete action method just picks out an action and gives all the information needed by the loop to actually perform that action. So this is the part where it actually says, given the current state of things, given the current context that I've been provided, given the current action that is supposed to be performed, and given the tools that I've been given to use to perform that action, and given this perception, here's what action should be taken at this particular step, and then the logic for that is all done here. And so with that, we've technically gone through how the assistant project actually works. And yeah, it's an NPM package that you can technically use. If I go over here to npmjs.com and I go to Quasar Brains Assistant, then you can see that it shows up. This is a real package. You can install it like so, and you can utilize it, and I'd be very interested in feedback. So that's one of the things that I've been working on, along with the GPT developer project, or the the junior GPT project that I've kind of been working on as well. And I'd be very interested in people's thoughts. If you want to start, I wonder if you can start a discussion in here. I'm not sure if like discussions is a thing in here, but if you have questions, either email me, which I have some information to reach out on my GitHub profile, or just generally leave a comment and do whatever. Just let me know what you think. If you try it out, give me feedback. I'm really looking to make this an actual useful thing. And so, yeah, that's something I've been working on. Thank you for watching, if you have, and I will see you all in the next video. Hopefully I'll be making an update on this sometime soon. So, see you guys.